Section 7.3 is called Triangle Similarity. And if you remember from last semester, we did a section on triangle congruence, right? Where we had to compare two triangles, and if they had a certain amount of sides congruent or a certain combination of angles and sides congruent, then they met what we call congruence. Okay? There were 5 of them. Can anybody name one of the 5? That's a type of triangle. So one of them is side, side, side.
Oh, side, angle, side.
Angle, side, angle, side, angle, side, angle, angle, side. Anybody remember the second one? Uh-huh. Hypotenuse. Congruence.
Oh, we already did that.
Congruence.
You.
Uh-huh. So there were 2 that did not work. The one that spelled a bad word, right? Uh-huh. And angle, angle, angle does not work unless it's a hypotenuse leg, which means it has to very specifically be a right triangle. Okay? With congruence, you had to have congruent sides, and you had to have congruent angles. Okay? So similarity is similar, but a little bit different, right? Similar has the word similar in it, right? Okay, so there are 3 that work. The first one that works is angle, angle. The second one that works is side, side, side. And the third one that works is side, angle, side. But you don't have to have everything congruent like you did with congruence. With the sides, they just need to be proportional. Should have written that first. They just have to have proportional sides. So they have to have the same ratio. So if you compare some sides, you set up a ratio, you can reduce it to the same number. Or you set up a proportion, do the cross product, and you should get the same number. The angles need to be congruent, just like with congruence. So this stays the same, this is just slightly different. Okay? So here's the type of questions you're going to see. Example number 1. Yeah.
What is proportional?
Proportional means they're going to have the same ratio. So if you have the sides, if your 2 figures are drawn the same way, you match up the sides, set up a ratio, they should reduce to the same thing.
Yeah.
Okay? All right. So this needs to go to 2. I would do it later. Like if you're walking by the front later, I would just take it then. All right. So you're going to be given a figure. You're going to be asked, are they similar? Yes or no? And if so, by which of these 3, right? Angle, angle, side, 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 or side, angle, side. Okay? So with these 2 triangles, you're going to notice that this one is slightly turned. Okay? So if you took ABC, turn it down, it would match up this way. If it helps you to redraw it, redraw it. But you can see what's going to match up if you just took ABC and turn it, right? First thing we're going to notice is that we do have some marks already. We have angle A with this little box, and angle D with this little box. What does that little box mean?
Right.
Right angles. So we can say that angle A is congruent to angle D because all right angles are congruent. Okay, so they're both 90 degrees. So we have our A, right? So if you look up here, we should either aim for this first one or this third one, right? Do we know any of the measurements of the sides? No. They didn't tell us any information. Is there another way to get another angle from each triangle congruent to each other? Yes, right? You see how we kind of have this X in the middle here? That makes a pair of what angles? Vertical, right? So this angle and this angle are vertical. Let's try that again. Vertical angles. And vertical angles are always congruent. So if I mark it with an arc and an arc, I can say that angle BCA is congruent to angle ECD. Why? Because they're vertical. And so now we have angle, angle. Is that enough to prove similarity? Yeah, it is. That's our first one, right? We only have to have two things. Those two angles have to be congruent. So we say that yes, these two triangles, triangle A, B, C, and because it's turned, right? I started with the right angle, went up the shorter side, and then down the hypotenuse. So I have to start at the right angle, go up the shorter side, and then go down the hypotenuse. So triangle DEC. And then I'm going to put the similar sign in the middle, not the congruent, the similar sign. They are similar. And I'm going to say by angle, angle, similarity. Okay? So on the assignment, you're going to be asked for something called the Similarity Statement. Okay? We did one in the last notes, but just so you see it again, this is a similarity statement. Make sure that your vertices match up. And like I said, pay attention to if one is turned or flipped. If it helps you redraw, if to redraw one of them, then redraw it. But most of you can kind of turn it in your mind. Okay? Any questions on example number 1? All right. Example number 2. All right, here's some example number 2. Here's your 2 triangles, okay? And what did I mark or give measurements for on these 2 triangles? Sides, okay? All 3 sides, all 3 sides. So if I'm trying to prove similarity, which one am I most likely to use? Side, side, side. We just need to prove that the sides are proportional, okay? So if the 3 sides are proportional, then we can say that they are similar by side, side, side. Okay? So notice that this one is split, one of them flipped, obviously, right? So I've got these 2 sides which have the same measurements, and these 2 sides which have the same measurements. So I'm going to set up their ratio. 3 to 4.5. If I take both of those numbers and divide them, by 1.5, or 1.5, because they're both evenly divisible by 1.5. What is 3 divided by 1.5? How about 2? Who goes in there twice? Thank you. And 4.5 divided by 1.5 is 3. So I get 2/3. Okay. Then I've got the two sides that are left over. From this triangle, it's a 2. From this triangle, it's a 3. And obviously, I don't need to reduce them because it's already the same. They reduce to the same. All right, so when you reduce them, as long as they end up at the same, they may not start the same, clearly, but if you can reduce them to the same ratio, you say, yes, they are similar by side, similarity, SSS. Make sure you put the little similar symbol. Otherwise, it's going to look like congruence, okay? And then you'll be asked to write a similarity statement. So we'll say PQR is similar to triangle STU. All right? I'm going to move this up and see it in just a second if you're still writing. And then I've got one more example for you. That would be example number 3. Bless you. All right, so there's my 2 triangles. Let me give you some measurements. All right, there's your measurements. All right, so the second triangle is obviously rotated or turned, okay? So first thing you want to do is you want to make a mental note of, what all is labeled. So on this one, we have a side, an angle that's in between them, right? Remember that angle always needs to be included if that A is in the middle, and then a side. Same thing on this triangle, a side, and then an angle, and then a side. So if they're turned or flipped, or both, you want to make sure that your sides match up from the shortest to the shortest, and the longest to the longest. So on this triangle, between 2 inches and 5.8 inches, obviously the 2 inches is shorter, okay? And then on the second triangle, you've got a 2.9 inch and a 1 inch. So obviously the 1 is shorter. So we've got a 2-to-1 ratio. Just so happens that we can't reduce that one, right? Okay, now let's do the longer sides. We've got the longer one is 5.8, or the bigger triangle is 5.8, and the smaller triangle is 2.9. So we want to see if we can reduce 5.8 to 2.9. How could you check that? Because they're decimals, right? What could you do? Divide them both by? Try dividing it by the smaller one. What's 5.8 divided by 2.9? 2, which means that if we divide by 2.9 and we divide by 2.9, we get 2/1. Notice that these ratios are obviously the same, okay? Then that's the sides. Now we have to check the angle. This one's 70 and this one's 70, so we're good. 70 obviously equals 70. So the sides are proportional and the angles are congruent. So we say, yes, these 2 triangles are similar by side angle.